Hello friends, today's question is minimum window substring. So what is given in this string is we are given two string s and t of length m and n respectively. Okay, so what we have to return? We have to return the minimum window substring from s such that every character of t is included in that substring including duplicates. Okay, so what basically given in this question is we are given a two string s and t, and we are given we have to return a substring from the string s such that it contains all the character from t. So if we see this example now, so this is the first substring which contain all the character from the t, like a b and c. Okay, now another is b a and c, so this is the second substring which contain all the character. Okay, let's see it here. Okay, so this is the first string which contains all the character from t, and this is the second string which contain all the character from t. Okay, this is the this is b c. This is another substring which contain all the character from t. So like there are we have to find a substring which contain all the character from t, and that substring too of minimum length. So like among these substring, this is the substring of minimum length, that is 4. So this is our required answer. So this is our required answer. So we have understood the question. Okay, so now for the solution approach. Okay, so first of all, the foremost thing which like brute force approach that comes in our mind, so is like we can find all the permutations, like we can find all the valid substring from this string s, and then we can check whether it contains the all the character from the t and having the minimum length. So if a valid substring from this string s is of minimum length and contain all the character from the t, in that case we will say that like okay, this is our valid substring. Okay, but for like if we go through brute force approach and we will apply that brute force approach, that it will take capital O of n square time complexity, because first to find all the permutation, what we will do, we will keep one pointer here and then we will increment another pointer and find all the permutations. Okay, so the string will be iterated two times, so minimum it will take capital of n square time complexity. But we have to find the optimal solution and we will look for the optimal solution. So we will apply here sliding window approach. Okay, sliding window approach. So what we will do, like okay, first of all, for any window, for every like for every window, like if we consider this window, we have to check whether the character contains in this are like all the character from the t are contained in it. Okay, so each time iterating to this window and finding or mapping those character, what we can do, we can have a map here. Okay, which will contain all the character from t. So we can have a map for t. So like for example, we can have a map which will contain all the character from t. So here a will be one time, then v okay, we are having b, that will also be one time, and then we will have c, that will also be one time. Okay, so this is our required map. Okay, where each character has a frequency one time. Okay, now what we will do, we will start from here, like left, we will have two pointer, left and right. Okay, both we will start from 0. This will keep track of our window. Okay, now what we, another thing which we have to record, like okay, so when we will get to know that okay, all the character of the t are present in this substring, so what we will have a count variable. The count is equals to t dot length, so it count, let's say count is equals to C. So every time we encounter a character from this t, we will decrement the count. Okay, now we will also maintain a start start and minimum length. Okay, minimum length for now, let's say it contains int max value, integer int max value. Okay, int max value, and s start from 0. So what we will in starting, or in s, we will keep the starting index of a substring from where we have started a substring that has all the character from the t. So what we will do, okay, so if we go through this, we will start from here. So left is here and right is here. Okay, what we will do, we will increment. Okay, now we will check whether its value Okay, our current character is L. Okay, so what we will do, we will decrement the value from A, so it will become 0. Okay, and we will decrement the count also, 3 becomes 2, and L will be incremented to next position, so L will be here, so D is not part of it, so we will ignore it. Okay, then it will increment to O, so O is also not part of it, so we will ignore. Now B is the part of our substring, our required string T, so we will decrement its value, and we will decrements the count, so it will become 1. Okay, now again we will move forward, and L will be move forward, so E is not part of our T, so we will again increment, so C is part of our T, so what we will do, we will again decrement the count of the C, it becomes 0, and it's become 0, count becomes now when count becomes 0, that means we have encountered all the character from the string T. So in this case we will update the minimum length, so and we will update the minimum length and the value of start. Okay, so start is 0 and minimum length is 1 2 3 4 5 6, so minimum length would be 6. Okay, so our overall count become 0. So in this case we know that this is the potential string, but we have to find the minimum substring which can be our potential solution. So what we will do, we will uh, try to reduce the size of the window. So what we will do, we will start reducing it from the left side. Okay, so our right pointer is here. Okay, so what we will do, we will increment this pointer to point the next element. So what it will do, it will increment the value of so A value become 1 and C count will become 1, so it become invalid, our count become invalid. So whenever our count become invalid, what we will do, we will increment the left pointer. Okay, so it goes to O is not part of our T, so it again incremented, so D is also not part of T, so it will be pointing to E is also not part of T, so it will be pointing to B. Now B we have got, so we will increment its value to 1. Okay, now again, okay, B increment value is 1, but still, okay, it is not 0, so count remains 1, it's still invalid. Okay, now again L, so L will be pointing to A, so L will be pointing to A. Now A value becomes, it becomes 0, and its count also becomes 0. So again our condition is count is 0, so we will start removing element from back. Okay, so we will calculate the, for currently we will calculate the length, so 1 2 3 4 5 6 7 8 9 10, so 10 it is not a minimum, so we will not update as starting and minimum length. Okay, so now we will our count become 0, which is valid, so we will start removing element from backward. So D is not part of it, so we will increment the value of our R is not, O is not part of T, is we will remove it. Now B is part of T, but V value is already 1, so if we will decrement this value, okay, it we will decrement this value, our count still remain valid. Okay, so what we will continue decrementing the value. Okay, so so R will move forward, then it will move to C. Now this is another scenario. Now C, R point to C, and C value is already 0, so what we will do, we will R will move forward, and it will increment the value of C to 1, and it will again make count to 1, so again the our count variable become invalid. Okay, so what we will do in this case, we will start incrementing value from left, so left will be here, so N is not part of T, so again left will be incremented. Now C is part of T, so what it will do, it will do a value, it will decrement the frequency of C to 0, and it will make our count to 0. Now our count become valid again, so in this case what we will do, when our count become valid, we will calculate, first of all we will calculate the starting point and minimum length. So minimum length 1 2 3 4 5 6 7, so minimum length, so we will it is not minimum less than minimum length, so we will not update these two. Now we will count is 0, so we will start removing element from backward. Okay, so R will be, so O is not part of T, so it will be incremented. D is not part of T, it will be incremented. E is not part of T, it will be incremented. And B is the part of T, and currently if we will remove this, so it becomes -1, so this is not a valid scenario. So and our count So every time on each iteration we will okay, so again b encountered, so what we will do, we will increment the value of b to 1. Okay, now count will also be incremented to 1. Okay, so now in this case we will at each iteration we will update the minimum length. So for currently it becomes 4. Okay, and the starting points become r, so r is starting points become equals to r. Okay, now v becomes value 1, so it's again invalid. So what we will do, we will start incrementing the value from l. So l is now out of the loop, so this is our required string which contains all the character from the t. Okay, so I think we have understood this problem statement. Now let's look towards its implementation. So as we have implemented, okay, first of all we will have int s length s length, which will contain length of s dot length length, and then we will have t length, which will contain length of t dot. Okay, now what we will have, first of all we will check the edge case. If s length length, if s length like okay, if this the length of s is smaller than t, then in any possible scenario it won't be able to return the answer. So what we, if s length is less than length, in that case we will return empty string, okay. Now if it is not, then we will have our left pointer is equals to 0, then we will have right pointer that points to 0, sorry, that points to 0, then we will have a start that points to 0, then we will have min length that we will update at every iteration. So for currently it will have like largest value of integer int max. Okay, min length. Okay, then at last what we will, okay, we already have count that is equals to t length. Okay, so we will check while r is less than uh, s length, what we will do, first of all we will check if oh sorry, we have to do that. Okay, so we will have int vec vector, we have to create a map of 128 length, uh, uh, int vector, sorry, this is vector of int, it we will have names count that will have 128 characters, and each character is initialized to 0. Okay, so we, what we will do, first of all we will have here for char character ch in rt, because we are maintaining the frequency of t. So we will have count of ch plus plus. Okay, so now we will check if while r is less than s dot length. Okay, so if character of s of r where count in s of r is greater than 0. Okay, so what we will do, s of r is greater than 0, in that case we will increment decrement the value of t length, t length here is our count. Okay, then what we will do, we will increment the value of r, and we will decrement the count of s of r, will decrement the count here. Okay, so like these two line we can do it here only, we can use post increment, so rr will be plus and rr will be minus, so we can remove these two values. Okay, okay, now we will check. Okay, while rt dot length tlength t length is equals to 0 until like, okay, so this is the case where our t length become our count becomes 0 and we start removing element from back. Okay, so first of all what we will do, we will currently check if min leng th length is greater than currently r minus l, then what we will do, we will update the value of start. Start is equals to l, then start is equals to l, and then min leng th length is equals to r minus l. Okay, now what we will do, if now we will check if whatever the count of character, okay, like s of r, so count of s of r is equals to 0. Okay, and what we will do, we will increment the count. Okay, uh, okay, if it is equals to 0, and now then what we will do, we will increment the value of r again. Okay, and then we can do these operations here only. We can increment the value of r and then we will increment the frequency of that count. Okay, so now this is the case. So in this case we will remove element from back. Okay, and we will update our map in this. Okay, so at last, okay, whenever our loop is over, what we have to return, we will first of check if minimum length length is equals to int max, sorry, oh sorry, again int max. If it equals to int max, then what we will do, we will return empty string. Okay, else we will return s dot sub str, from where we have to start sta rt start. For this we were maintaining start variable sta rt start, then minimum length min ng th length minimum length. Okay, so this is our required solution. Let's submit. So it is accepted. Now let's submit. It is submitted successfully. Now for the time complexity, for this as we are iterating this string for the one time, so its time complexity will be capital O of n, and its space complexity, as we are using linear space of 128, so its space complexity will be capital O of 1. So this is our required solution. Thank you for watching.